Hi dear students, this is Pseudo, a system professor, Department of Chemistry, Berkeley Education Society's Arts, Commerce and Science College, Jawahar District College. Dear friends, if you remember about the last lecture, then in the last lecture we particularly discussed about the second order reaction and the various characteristics of second order reaction. We also discussed about the unit of second order rate constant, then the graphical representation, and the time required for the completion of half-life period of second order reaction. And definitely we got the relation. The first order rate constant is inversely proportional to the initial concentration of reactant. Dear friends, based upon the first order reaction, now we are going to talk about the another important topic in the chemical kinetics entitled as pseudo order reaction, or it is simply called as pseudo molecular reaction. Dear friends, generally it is observed that in some reactions solvent molecules also involved chemically, and these are taking part in the reaction. So from the chemical equation, the rate of such reactions can be written in this way, that it indicates the rate of reaction depends upon the concentration of reactant as well as concentration of solvent. Here you can see the here simple reaction, that is ester undergoes hydrolysis and it gives the two products. One is acetic acid and another one is alcohol. So from this equation, if you write the equation for the rate of reaction, then this rate of reaction means dx by dt is depends upon the concentration of ester as well as concentration of water, and that's why here we can say that here the rate of reaction depends upon the concentration of the two reactant. One is that is in two species, means one is reactant and another one is the solvent. So expected order of this reaction should be 2, because in the rate equation the rate of reaction depends upon the two species. That's why the expected rate of reaction, expected order of this reaction is simply 2. This is the expected order reaction. But actually in practice is found that it is found that whenever the reaction process, the water is present in the large quantity, large excess, and hence the amount used up in the course of reaction is very negligible. It means that the change in concentration of water during the course of reaction is negligible in comparison, or as compared with the other molecules, and hence, or as compared with its total concentration, and hence the concentration of water is simply considered as the constant, and that's why as there is no change in the concentration of water practically, so the actual equation for the rate of reaction can be written as dx by dt is directly proportional to the concentration of ester, and this is the practically, this is the actual, and actually from this equation, from this rate equation, the actual order of reaction is nothing but 1, or it is simply 1, and such reactions are called as speed order reaction. What is speed order reaction? It is simply the reaction whose expected order of reaction is not equal to the actual order of reaction, or the theoretical order of reaction is not equal to the actual or the observed order of reaction. Or simply here there is another definition of speed order reaction can be also defined as the reaction in which molecularity is not equal to the order of reaction. It is also called as speed order reaction, because here you can say what is the molecularity as the two species, two reactants involved in the chemical equation. So the molecularity of this reaction is 2, but actually the order of reaction is only 1. So here in this reaction, order is not equal to the molecularity, and hence these reactions are called as speed order reaction. And if in this case, if the order of reaction is 1, then these are simply called as the Pseudo first order reaction. It's very simple. I hope you can understand this very well, and there are so many examples. And one of the example of Pseudo first order reaction is inversion of cane sugar. It is a Pseudo first order reaction. It follows the kinetics of first order reaction. That's why it is called a Pseudo first order reaction. Another example in which the reaction follows Pseudo first order kinetics, in which the two molecules react, but one of the reactant is formed at the end of reaction, and that's why rate of reaction depends upon the concentration of only one reactant. That is conversion of N-chloroacetanilide into parachloroacetanilide. So this reaction is also involved in the two spaces, but here actual rate of reaction depends upon the concentration of only one species, N-chloroacetanilide. That's why the order of reaction is 1. So how can we determine the order of reaction? This is also the important thing, and this order of reaction can be calculated, can be determined with the help of various methods. The first method is called as the integration method. Second method is called as the graphical method. So this is the important thing, and next one, last one is nothing, the diffraction method that we discuss later on. In the integration method, this is very simple one, because in the study of chemical kinetics we discussed about the rate constant for the first order reaction. K1 is equal to 2 upon 3.3 K is equal to 2.3 not 3 upon T log to the base of A upon M minus 6. And for the second order reaction, the rate constant is given by K2 is equal to 1 upon A into T into X upon A minus 6. In this method, in this integration method, what we have to do? We have to find out the values of A, B, which are the initial concentration, as well as X concentration plot formula, and we have to put these values in the rate equation of first order as well as second order, and these values are substituted in the respective expression, and the appropriate rate equation will give a reaction is that which provides a constant value of specific reaction rate. Means this is trial and error method. So for if we are getting the constant value of specific reaction rate, that will be the order of reaction. If you are getting the constant value of K for first order reaction, then the order of reaction will be 1. It will be first order reaction. And if you are getting the constant value for the rate constant of second order reaction, then the order of reaction will be 2, and it will be second order reaction. In the second method, graphical method, actually this is one of the characteristic of first order as well as second order reaction. In this case, we have to calculate the value of A, X, B, A minus X like this, and we have to plot the graph of for the straight line y equal to mx plus c with the help of first order rate equation as well as second order rate equation. So this is the second order, and this is for the first order. And if we are getting such type of the straight line, then if we plot the graph of 1 upon A minus X versus time, this is for the second order reaction. And if you are getting such type of the graph, then it indicates the order of reaction is 2, and it will be second order reaction. And if we will plot the graph of x upon A minus x versus time, and if you are getting the straight line passing through origin, that will also indicate it is the second order reaction. In the next method, equifraction method, and this is general expression for the time to complete half-life period of the reaction. And for the first order reaction, the half-life is independent of initial concentration, and for the second order reaction, the half-life is inversely proportional to initial concentration. It's very important. I hope we'll keep in mind that for the first order, half-life period is independent of initial concentration, and for the second order reaction, the half-life period is inversely proportional to initial concentration. And for the help of this, we will write the equation for the relationship between half-life period and the initial concentration. In general ways, T1 by 2 is directly 1 upon A raised to n minus 1. N is the order of reaction. A is the initial concentration. And simply we will write the same equation for two different initial concentration, A1 and A2. And definitely by taking their ratio, we will get this equation. And after simplification, as well as by using the log, we are able to simplify the equation in this form. Finally, we will get the equation for the order of reaction. N is equal to log of T1 by 2 1 minus log of T1 by 2 divided by log of A2 minus log of A1 plus 1. A1 and A2, these are the two initial concentrations. T1 by 2 1 and T1 by 2 2, these are their respective half-life period. Hence, in this way, we are able to calculate the order of reaction in the value of Vn with the help of this equifraction method. So these are the three methods: the integration method, graphical method, and the time for equifraction method. These are the three methods which are generally used for the determination of order of reaction. So dear friends, in this way we have completed the first topic, chemical kinetics. Here after this we will discuss about the liquid state, and then we will move towards the stereochemistry. So thank you. I request you all to solve some numericals, some MCQ. True or false, match the column based upon this chemical kinetics given in the exercise in the textbook of Himalaya publication. So I request you to solve. In case any problem, you can contact. So dear friends, thank you very much. We will resume in the next part of the video to discuss about the liquid state. So thank you very much.